Welcome to IT Pro TV. I'm your host, Don.
Coming at you live from San Francisco, California.
You're watching IT Pro TV.
All right, greetings everyone, and welcome back to another exciting episode of IT Pro TV. I'm your host, Daniel Lowry, and in today's episode, it's all about the A+ series. That's right, always back for the good old 22901. Don't you just love it? Let's just ruminate in it, and here to help us stew in that juice is our good friend, Mr. Wes Bryan. Wes, we're glad to have you back today, and how's it going?
Well, now you're making me hungry. Now I'm thinking of stew, that's
I gotta
for sure.
have food.
That's right.
Cut the camera.
we're gonna move into part 3, as you can see here, and we've been talking about some different issues that you can face with your motherboards and CPUs and RAM, and we've shown some stuff, but we really want to kind of, in this last part, kind of show you some of the things, the physical hands-on parts that you might end up seeing when it comes to being some kind of A+ technician, or if you're working the tech bench, or maybe even help desk. So that's really what we're going to take care of here. In this last part, guys and gals, because we've been saying that, and well, we've just been, the cliffhangers right there towards the end. So
we keep promising and not delivering.
That's
but
right.
Today's the day.
That's right.
This is the show.
We're going to make like Cliff the Mailman, and delivery has arrived.
That's right.
Yeah, some of you guys might understand that. Some of you, Cliff, who's he? But go check it out for sure.
Cliff Clavin.
Google will be your friend on that one for
Google
sure.
Cliff Clavin.
So when we talk about some of the issues that you could face, some of the things that you could see. One of the things that we had talked about in the previous episodes was, your BIOS time and settings are reset. Right now, don't let that term BIOS time confuse you, because I also said CMOS settings. So, what are we talking about? Just remember that when they say BIOS time, generically, you might even hear the term BIOS CMOS, and those are just because they use them interchangeably today, right? And that's just the fact that that complementary metal oxide semiconductor is what really is helping you to retain the user-defined settings. And in the BIOS ROM chip, right, read-only memory, you've electrically flashed or electrically programmed the EEPROM chip to retain those firmware settings. So again, kind of using them interchangeably. Keep in mind that it is the CMOS battery that is what provides the voltage for those settings. Now, one of the things that we went ahead and did is we've got a computer up here, and if we could take a look at it, you can see that we've got kind of like the side already taken apart here, and we're going to show you some of the tools, because that's one of the things that they talk about in the objectives is, using the appropriate tools. Well, one of the tools that we have is what is known as the power on self-test. So we're going to go ahead and kind of show you what you would see. Let's say, for instance, if you were, first of all, maybe replacing one of these batteries for the very first time, or the battery had outright failed, and then you had to replace it. So we're going to go ahead and we're going to start up this machine, and what we want you to see is the post screen. Now you'll notice if we bring up that post screen, right? Well, the computer screen, it's going to be blank, right? It's going to be pretty much all blank. We were not going to see anything. What we're going to end up seeing is really just a black screen, right? And that's okay, because the machine doesn't have any power. But let's go ahead and let's look at the power screen. All right, Dan, now this is what we should be seeing if we don't have any power on the machine here. So what we're going to go ahead and do is we will power this machine up, and we should see some kind of BIOS screen come up, right? So we'll go ahead and we'll press power, and sometimes it takes a little bit to see the screen, depending on what kind of firmware that you have in the machine. Sometimes you might have a dual firmware, and if it's in the process of rebuilding one of the BIOSes, if they end up getting corrupted, it could take a good bit to even see anything. Now you can see that it is trying to go through its basic boot, right? And notice right away, this is something that we kind of wanted you to see. Notice it says performing automatic IDE configuration. Now, why is it performing some kind of automatic configuration? Well, it should already have configuration stored, right? And now it's trying to check hard drives, and notice that we get a failure here. And if we look at what that failure says, time of day not set, please run the setup program. Notice that it also says invalid configuration information. And again, you guys can read along with me out there. Please run the setup program. And then again, in that next sentence, it says system management hardware requires a reset, right? System setup configuration and date and time require attention after the reset. So what's going on here? All right, well, what's going on is this little battery that we have inside of the motherboard has failed to do its job, right? And this is indicative of some kind of CMOS battery failure. Now, what battery do I mean? Well, I've actually got one right here in my hands, right? This is it, right? It's a little I believe CR2032 3-volt watch battery, right? There's nothing really special about it, except for in your computer. There's something very special about it. It's holding all of these configurations. And now that we don't have power to those configurations, volatile memory, right? Even if it's low voltage, if it's volatile memory, no voltage means no configuration. So this is what you can see if you have the BIOS settings are reset, like they say, the BIOS time and settings keep resetting. Well, it basically means this is the problem. This is the little battery, right? And one of the things that you also want to keep in mind is that in a home environment, again, sometimes I've seen where we haven't ever changed these at all. But in a production environment, that's not something you want to risk, right? Especially when we're talking about server closets, right? And we talk about server closets where you have a potential of thousands of servers. If even one of those servers goes offline and you don't have some kind of redundancy, not likely that you wouldn't have some kind of redundancy, but it could cause a very, very bad day at the office, not for just you as a tech, but also for the company, right? As you guys go on to additional training here at the CompTIA level, you'll progress through Net Plus and Security Plus. You'll learn about business continuity, right? Well, your business can't continue if we have issues like that. So that's one of the things that we can hear in the post error code. You heard the little beep right there. It's telling me something is wrong, and that's some of the things that you could see. So keep in mind that you have those audible beeps. Now that's not the only audible beep that you could hear too. What if you end up having memory issues? All right, well, if you have memory issues, those will give you certain types of beeps as well. And like Dan and I have already stated, keep in mind there is a consistency and inconsistency, if that makes sense, between the manufacturers on what kind of codes, error codes you'll hear. For instance, Dell, they're basically like an IBM PC BIOS. They still have the traditional PC BIOS, but they have their own dedicated codes, right? HP's one that's got a very limited amount. So again, pay attention to that. So let's go ahead, and what we're going to do next is we're going to figure out what happens if something goes wrong with our memory. Do we get some kind of post-audible beep there? Is it something that we can tell when it runs that self-diagnostic? So we'll go ahead and take a look at that next. All right, Dan, so I think what I'm going to do is simulate a failure that can kind of happen if a tech gets into, kind of a hurry, if they're replacing a motherboard, replacing RAM. So you'll notice if we look right down in here, I've actually removed the RAM altogether. We don't have a memory module in here. And what we're doing here is we're simulating when somebody goes to install RAM and they don't properly seat it, right? It doesn't make an electrical contact to the motherboard. It's going to cause some kind of issue. Perfect. Look at that. Thank you there, Dan.
Coming in with the spotlight.
The interesting thing about this is with the Dell machines here, they kind of have a post before you even hit the power button. So you're going to notice that I don't even have to reach out here and hit the power button like we did before. I'm just going to plug the machine in.
Gets real angry.
It does, doesn't it? It's not too happy at me, Dan, right now. Did you notice that it had some specific timings of that beep, right? That isn't like a metronome to your favorite, I don't know, blues song here. Yeah. Let's go ahead, and we're going to unplug that one more time, and I'm going to dissipate all the electrical current out of here by pressing the power button and holding it in. And notice that little light there just behind where Dan's shining that light. Notice how it dissipated and it went out. That lets me know there's not any residual electrical power on the motherboard. And we'll do this one more time. Yep. All right, so it's letting me know that there's something wrong, and that would be something here where we would actually have to go to Dell's website, right? I don't know what those codes are. We kind of joked around. I showed you all the different pages that we had of codes here. I did that just for the purposes of showing you guys that there's a lot of them out there, right? So at this point, and I've had to do this too, I've done Dell warranty calls and stuff and had to talk to technicians, and they go through a process where they say, well, did you check this? Did you check this? Did you check this? And then at the end, they say, well, have you heard any kind of error codes? And you say, yeah, well, what's the error code? And you try to tell them. And they've got a great customer service base, too. And you can even kind of hold the phone over, and the tech can listen and say, oh, okay, I know what that is. Let me look through my manual real quick, and I'll tell you some of the steps that we can go through before we just, let's say, ship you out new parts. So what do we have to do here? Well, what we end up having to do is we have to reinstall the memory correctly. So let's go ahead and let's do that. Let's take a look at the machine here, and what I'm going to do the same thing here, ladies and gentlemen. I'm going to pull the power, All right, it's important, press the power button, and that's what I'm doing here on the front side of the case, and we'll just hold this power button in. And it's real important, and the reason we didn't show you the front, because all I'm doing is holding the power button, I just wanted to see that light just kind of gently just fade away. And again, it lets me know that there isn't any residual power in here. Now, you might be asking yourself, Wes, where's your ESD wrist strap, right? Yes, memory, we realize memory is very, very sensitive to electrostatic discharge, but keep in mind, I am dissipating any electrical current in my body to the case right here just by touching the inside of the case. And both Dan and I are actually standing on electrically resistive mats, which is a commonality when you have, some kind of tech bench. Sometimes you'll see the mats are actually on the bench itself, and they have a little snap button that'll let you clip on the ESD wrist strap right to the mat itself. I kind of find those a little bit restrictive.
Nowadays they make the floor
Yes.
out of ESD
Most
material,
definitely.
yeah.
In fact, our server closet, I believe, was made out of that because we've got thousands of dollars of equipment.
Don't want to mess
sitting.
that up.
That's right. That's right. That would be a really bad day
That'd
at
be
the
bad.
office.
That'd be a bad day.
So let's go ahead, and what we're going to do, we're going to dive back into this machine here, and let's go ahead and install some RAM modules. Now, I do want you to understand that I'm not touching the integral chips, the little chips here. Thanks, Dan. I appreciate that, bud. And what we're going to do is we're just going to go ahead, and we're going to install this, right? We're going to make sure that we line it up appropriately so that we don't get another one of those beep codes. And you should hear these snap. Now I'll try to be a little quiet here, and you can hear those click on both sides. That's what you want to hear, right? Rather, you don't want to hear crack, 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 right? But
that means it's in backwards.
That's right, that's right. You don't put these in. There you go. There's a second one here. All right, and a third one. All right, and what we should see, again, there's the other one. Keep in mind that you have to, if you've got dual channel memory or triple channel or quad channel memory, you want to make sure that you're installing these in the right order. One of the things that we did say, there we go, so we got our memory installed. One of the things that we did say inside of the memory module section was that if you are populating every one of the RAM slots, the DIMM slots on the motherboard, then you don't have to worry about the arrangement, right? So do keep that in mind. Now, what I'm going to do here is I'm going to go ahead and I'm going to plug this machine back in, and we shouldn't hear anything. Now, keep in mind that we still have to reset the CMOS settings because of the fact that we don't have we don't have our date and time right. We'll go ahead and we'll kind of show you how that works here too. So I'm going to go ahead and I'm going to plug this back in. And I don't know if you can hear that run, right? But we don't seem to have any issues. Now, the other thing I want to kind of show you too is while we're in here, I'm going to go ahead and I'm going to unplug this one more time. All right, and again, notice our light here. I like these lights that they have on the motherboards today. I'm holding the power in, power button that is, and again, it dissipates. Let me know again that there's no residual electrical current still remaining on the motherboard. I still wouldn't open a power supply to save my life. You never do that at all. I don't care if it's plugged in or not.
Actually, it might save your life to not.
It might say. Thank you for getting that English correct on that one, Dan. I'm going to go ahead, and if we can kind of zoom out a little bit, kind of see the bigger picture here. Perfect, thanks out there. And I'm going to undo, and what I want to do is I want to take this graphics card out. So I'm going to undo the video cable here, and we'll just kind of put this down. Remember that I was joking around. I'm going to take this PCIe card out here real quick. Remember I was joking around. I said, hey, we're going to mail Dan a postcard. And I said, okay, technically not really. Well, we actually have a PCI postcard installed in this machine, and these are really good. And again, Dell does something a little bit different. Dan, you mind holding that up just on a diagonal there, bud, real quick? If I plug this in, watch your finger there, or I'll plug you in. Notice the lights here, and we get the little digital readout here, and it's telling me a 0, 1 there. Well, if I push the power on this machine and it starts to go through its post process, that postcard gives me a visualization of the post process even if I don't have it hooked up to a monitor. So if I have a video card that's failing, let's say, or something on the motherboard's failing, I can see the post process go on and I can get a digital readout, and then, thank you, sir, and then what we end up doing is whatever the card might be, you just go check out and see what what the readout actually says. But I can see the lights that are going on here, and that's one of the things that you have. When we talk about the postcard, now you could also have this where it's hooked up to USB, which is really handy because then you don't even have to take off the case, right? You just have to plug it into the back plane of the motherboard, not the back plane, but the back I/O devices, right? And then what it'll do is it'll do the same thing. It'll give you those post numeric codes, right? Or it's got an external speaker, right? Now, keep in mind that every one of these might be a little bit different, so definitely check with the manufacturer. And you can hear in the background that beep beep. Again, it's letting me know a couple of things, right? It's letting me know that either it didn't find a boot device because it doesn't even have an operating system to begin with, or we still need to set the system time. All right, so what we're going to go ahead and do, we're going to use the magic of television here, and we're going to recreate the error, and we're going to enter into the setup utility so that we can show you exactly how, if this happened to you and the BIOS settings were reset because of a failed CMOS battery, what it would look like to bring those back online and then reset that time. All right, Dan, does look like we got our memory back in place here. We've got our CMOS battery set back in. We've got our graphics card ready to go. We're going to go ahead and plug this in, and a couple of things could happen. Sometimes the power comes right on. Sometimes it doesn't. We'll kind of see which one this one's going to do. We'll go ahead and we'll press power on this machine here.
See some lights.
Yeah, we see some lights on that. I'm glad that postcard's still in there as well.
That's helpful.
And depending on how your BIOS is, again, sometimes you'll see that if there's a corruption in a BIOS, I know like some gaming boards that I have, one of the boards that I have at the house has a dual BIOS, and what'll happen is it might take a little bit for the BIOS screen to come on, and what's happening is it fails over to basically a protected BIOS, and then they kind of overwrite each other, and it'll rebuild the first one. Sometimes you can see here it takes a little bit for these to come on. Sometimes, you know, they end up booting right up. Might be one of these things where, hey, it doesn't, because we have removed the CMOS battery, that it might not come on right away. You know, you can see right now, again, it's going through that automatic IDE configuration, and you got to keep in mind what's going on. If the BIOS had retained those settings, it looks directly to the CMOS, right? And it just loads up those settings. Since those settings have been erased, it takes a little bit longer because it's got to pull the BIOS configuration that's, you know, loaded in the EEPROM chip and basically loaded into RAM. So it takes a little bit longer, and you can see that it's going through, you know, some kind of diagnostic / configuration here. So we'll give it a second here. And it might be one of those things that you can even, sometimes what you can do is you can actually kind of, you can even reboot the machine. So if it doesn't end up working, you can always do the Control-Alt-Delete. You can reboot the machine.
Salute.
Yeah, that's right, absolutely. And I don't know if that actually did it on this one. Yeah, okay, there we go. And we'll kind of show you what's going on. Now, I do want to show you too, remember we see an invalid configuration. Notice that when the machine rebooted, it didn't do that automatic configuration this time. Why is that? All right, well, when you reboot a machine like this, okay, so we are getting the system hardware reset, but we're not getting the time, right? Why is that? Well, because it didn't have a time configuration on the first boot, and it gives you invalid time settings. But then what it does when I just rebooted the machine, it says, oh, okay, we've got a time that still remains in the BIOS. We'll go ahead and we'll put that, and we'll set that as the system time, and it kind of fixes itself. Now, technically, it doesn't fix itself, right? We still need to go in and configure it, but it at least allows you to perform the, you know, the full boot process. So let's go ahead and let's get into our setup utility here, all right? We're just going to press F2, just like it says, run the setup utility. And what we should see here in a second is that it boots right into the standard BIOS screen. All right, so if we can bring that screen back up here, and we'll see, hopefully it'll get there. You know, sometimes it takes a second here. When it gets in there. We could run, again, onboard diagnostics here, but we'll see what's going on here. Give it just a little bit more. Sometimes you can get right into the settings. I'm going to go ahead. It looks like my keyboard doesn't like me right now, so I can go ahead and I can essentially hit F12 and get into the one-time boot menu. One of the things I like about these Dells is you'll see in the one-time boot menu, it also allows you to get into the configuration utility as well. I'm not really worried right now about getting into the RAID array configuration because, well, we've already got a good RAID array configured. Now notice that we have the system set up. I'm just going to scroll down with the keyboard here, and we'll hit the system setup, and we're going to let that load up. Now again, this is one of those things where it isn't loading it from a hard drive, so it could take a bit to get in here. The first thing I want to look at is, you'll notice if we scroll down, is the date and time. Now notice this date and time, right? We're recording this, what is it, July 6th, I think you said?
Yes.
Yeah, thank you. July 6th of 2017. However, you see the time that we have up here, or the date, right? It says 9, right? And then it says 2010. Well, that's because that's hard-coded in the BIOS. So I have to come in here and I have to change, again, that date and time. Now, if that date and time doesn't stay when I reboot the computer, then that lets me know that the CMOS battery has failed, right? So we'll go ahead and we'll set that, and we'll set it to 2017. And I am going to kind of rubberneck Dan's phone. Looks like we got 10:46. We'll go ahead and set the time to 10:46 a.m. All right, and then from here, I can't remember if it's F10. My head's kind of covering this one up here. And what you can do is you can choose exit, and it will save my configurations. Now, when it does reboot, please understand that it isn't going to go into an operating system because we don't have an operating system, right? This is the same machine we used when we were showing RAID controllers failing and stuff. So notice that one of the things that we don't really see that is happening again is it shouldn't be giving us that invalid date and time. However, we would still need to show an operating system, right? So system hardware requires a reset. And again, that's because of the fact that we didn't do each one of the configurations for what we need. So we should be good as far as the date and time goes, but again, we would have to do some additional configurations, including installing an operating system to make this system fully functional. All right, so that's some of the things that you could hear with those audible beep codes, and it's some of the things that we wanted you to know, right? The last thing that we want to kind of talk about are some of the power issues that you might run into. So what we're going to go ahead and do is we're going to set up showing you how you could potentially diagnose if you have things like issues with, for instance, the power supply. So that's the next thing we're going to look at. So Dan, yeah, we were talking about power issues, and sometimes things don't really manifest themselves as if you know that it's a power issue. I can give you one example of where it is. So for instance, let's say that your CPU isn't receiving power, whether it happens to be a rail coming off of the power supply itself, or it could actually be, you know, the connector, whether it's the 8-pin EPS connector, or whether it's like the old P4 ATX connector, if that's failed. So what I went ahead and did is I went ahead and pulled, if you will, the P4 connector off of the board here, and it would be no different than if this failed off of the back of the power supply, or if that port itself, you know, the connector on the motherboard had fried.
So you're just simulating that failure.
Yeah, absolutely, yeah. So if we plug this in, this is an interesting one, because remember, one of the things that the objectives have called out that we've talked about is the fact that fans spin and nothing happens, right? So let me show you here. Notice that the fans are spinning, both the system fan and the CPU fan, and, well, they just instantly turn right off. So what it did is it noticed that, hey, I noticed that I have power to the 3-pin and 4-pin Molex KK connectors on the motherboard that control the power to the fans, but I've got nothing on the CPU. So to protect itself, the motherboard said, no food for you, and it shut itself down right away. So that's actually a good protection mechanism, letting you know that if the power supply goes like this and it isn't giving you any power at all, you don't have to worry about damage to the CPU. Now, that's not necessarily the case if the power itself is or if something's wrong with that little 4-pin connector there. So what would we do, right? Well, what we're going to go ahead and do is we're going to kind of show you how you could test, you know, the power supply itself. So that'll be the next thing that we're going to look at. So Dan, I guess if we're going to talk about power, the first thing that we have to do is a little disclaimer warning, right? So be very, very careful when you are testing any kind of power supply. Like we've said throughout the last few parts here that we've been in hardware, never open a power supply. Keep in mind that it does have capacitors in it that can retain their charge, just like the old CRT monitors that just on contact could stop your heart. It isn't something that you want to take very lightly. If you feel uncomfortable dealing with any kind of electrical power, then by all means, leave it to the people, you know, electrical engineers or people that do have the qualifications to test it. Now, that being said, there are some basic tests that you can run on your power supplies if you do feel like maybe the fans are spinning like we've shown you and we're not getting power to the machine, you can pull out your multimeter. So we've got a power supply already set up. So here's our power supply here that we have. Again, I think it's about 1100 watt power supply here, and what we're going to do is we'll go ahead and we'll turn it on here and let it start up. Again, you can see if something like this happened where the fan is actually spinning and you have no power, then that's pretty, a good telltale sign that something has failed on the power supply. Now, what we have here are the P4 connectors that I was talking about. One of the ways that you can test these, keep in mind our multimeter. So if we look at our multimeter here, notice that what you want to do is you want to kind of keep it to the setting there on the multimeter that is closest to the the voltage of which you're testing. So if we can zoom into the multimeter there, we'll see here that we got it set on the 20 volts, and that's as close to what we're going to be testing, because what we're going to be testing here is the 12 volt circuit, if you will. So I'm going to go ahead, and what I'll do is I'll touch this, the negative probe here to the negative side, and then what we'll do is we'll touch this to the hot wire, if you will, and you'll notice that the multimeter is letting us know that it is in the 12 volt range. So what I can see right here is that it's within its tolerances. Keep in mind that it might not be exact, and if it was just a little bit under, that might cause a problem. But if you're a little bit over, remember the device can only pull the amount of power that it's capable of pulling. Now, we could go a little bit farther than this, and then what I could do is I could pull over like one of these Molex connectors here, and we can show you, again, one of the other voltages. And this one's actually kind of a little easier to test out, because you can take your negative, your black is your ground here, and we could test, again, the same thing, just putting the black probe here into the ground, and then we can test, for instance, the yellow wire here, and you'll notice that same thing, we get our 12 volts. So we can see that from two different rails here that we're getting 12 volts off of each rail. I'm going to move this over a little bit so we don't arc out here, and we could test again the red, right? The red is the 5 volt, or it should be 5 volts. And you can see here too, we're right in a good tolerance here. So I can tell that this power supply is giving off the appropriate voltages that it needs to be, and I'll go ahead and turn this off. But that's something that you can see. Again, keep in mind that when it comes to testing the power supply, if Dan or I if we were sitting here and we were working on one of these machines, we could say, well, you know what? We know the power supply is good. We put the multimeter on it. It seems to check out. So then what would the other thing be? Well, it could be the motherboard that's failing, right? If you're not getting any computation out of the CPU, could be the fact that the CPU's failed, right? Remember to use your tools that you have. We've kind of shown you in the background some of the tools that we've had up here on the desk since we started. Your chip inserters, right? You have things like your thermal paste. Remember, that's the other thing. They did mention overheating. If you forget to put thermal paste, and it can happen if people get in a hurry. They don't put the thermal paste on, don't spread it out right. Remember, what that does is that leaves a metal-on-metal contact with the CPU. Actually, it leaves a really, really small air gap, and that air gap turns into an insulator, right? As it heats up, it just stays right there, and it actually can completely melt the CPU. So you want to make sure, for instance, when you're using a thermal compound and you're replacing a CPU, or maybe installing a heat sink, to make sure that you have that thermal compound on there. So those are a few of the things. Like we say, anytime you're dealing with any product that could have potential for damage due to static discharge, electrostatic discharge, remember, wear your wrist straps, or do like we're doing, stand on electrically resistive mats and ground out to the case to make sure that you're dissipating that energy, that electricity somewhere else other than the components that you're working on. Just again, I cannot stress enough, when it comes to electrical equipment, make sure you're dissipating all excess electricity or discharging any excess electricity. When you pull the power on it, when you're replacing parts, push the power button and hold it in for a little bit, right? And that'll make sure that any residual electrical current that is left inside of the system is dissipated. And be very careful if you don't feel comfortable doing what it is that they're asking you to do. Well, then escalate it. That's the reason you have escalation processes within the company that you're working for. Maybe you're tier 1, you want to deal with the software, you don't want to deal with the hardware, or vice versa. Only do that work that you're qualified for. And remember some of the things that we've shown you in this episode or this mini-series that we've been doing, so that if they ask you on the A+ exam, you'll be able to pass it.
Well, Wes, thanks so much for those cool troubleshooting demonstrations. Very good for us to not only understand the theory behind it, but to see it in practical application. So hopefully that helped you guys out there as well. We work really hard to bring that kind of content to you people, but guess what? I'm looking at the clock, and we've run out of time for this episode. We do thank you so much for watching, though. Signing off for IT Pro TV, I've been your host, Daniel Lowry.
And I'm Wes Bryan.
And we'll see you next time.
Thank you for watching IT Pro TV.